In a previous project video, I showed you how to create a coilgun that can shoot iron projectiles. The main component of the electronic circuit was an Arduino Nano microcontroller, which as you can see does its job just fine, but many viewers stated that they would love to see another approach with more classical ICs, without programming. So in this video I will show you how easy that sounds and how difficult it actually can get to recreate an Arduino circuit with common ICs, and what the pros and cons of this are. Let's get started. First off, I gathered all the ICs that I had laying around and might need for this project. Most importantly are so-called logic gates, which usually have one or more inputs and one output. There exist AND ICs, which only turn the output on when the input 1 and input 2 are connected to a positive voltage, aka R high, aka R1, however you want to call it. Then we have OR ICs, which turn the output on when input 1 or input 2 or both are high, not aka inverter ICs, which turn the output on or off in reverse to the inputs, and combinations of AND/OR ICs with NOT ICs to create NANDs and NORs. Another mandatory IC is the so-called RS latch, which consists of logic gates in order to maintain a switched on output even when the set pin switches from 5 volts back to ground. The reset pin can then obviously reset the output state to turned off again. And last but not least, we will need an op-amp as a comparator. While the Arduino was capable of distinguishing between the two output states of the optical sensor, the logic gates cannot do that. So the comparator will output the logic gate's compatible 5V level once the applied voltage on the plus inputs is higher than the reference voltage on the minus inputs, which I can adjust by utilizing a potentiometer. And with those basics out of the way, let's try to come up with a logic diagram. First off, the tactile switch, once pushed, needs to turn on the output of an RS latch, which then turns on the driver of the first coil stage. And if you're wondering why there is an inverter, my CD4044 RS latch has inverted inputs, so I need another additional inverter to get rid of that effect. Once the projectile then reaches the first optical sensor, the comparator turns on its outputs and resets the first latch, while simultaneously turning on the second latch and thus the second driver and coil stage. Ultimately, the projectile reaches a second optical sensor, which once again turns on the comparator, resets the latch and turns off the second driver. In theory, this logic diagram works, but imagine if something goes wrong and the projectile never reaches a sensor. The first coil stage would get destroyed by the continuous high current. The Arduino solved this problem with a timer, which turns off the drivers automatically after around a second. To recreate this function, we could use a 10 microfarad capacitor and a 100 kilo ohm resistor in series on the output of both latches. The 5V of the circuit will charge up the capacitor up to 3 volts in roughly 812 milliseconds. We could use this reference voltage as a trigger for an additional comparator to turn off the reset of the latch prematurely, which also forces us to use a logic OR gate. And in order to discharge the capacitor, we will need a bipolar transistor, which turns on once the output of the latch is low, which also requires another inverter. Now this logic circuit still has minor bugs, like if you hold the tactile switch forever, or that the second coil stage turns on when you insert the projectile. But for now, this is good enough. So let's create a proper circuit diagram. For that, I used the EasyEDA circuit design software because it was rather simple to find the required ICs in their online database. As you might already have noticed, not only the creation of the logic diagram took a lot of time, but also the schematic design as well, if we compare it to the relatively simple circuit of the Arduino. But nevertheless, once the diagram was complete, I went ahead and created a prototype of it on 2 breadboards. Needless to say though, it was a mess, simply because of the increased number of components and connections. Afterwards, I added male headers and the necessary wires to the Arduino socket of my coilgun, connected those to my circuit, fine-tuned the potentiometers for the comparators and tested it out. As you can see, the circuit without programming works fine as well. So I disassembled the prototype and realized that soldering the components to the bottom side perf board of my coilgun would have been impossible. For circuits of that size, etching a PCB or ordering professionally made ones is definitely more appropriate. And if we add the price of each IC from the control circuits, it would cost around €3. So we might as well order an Arduino from China for that price, whose functions in the circuits we could easily extend through software instead of hardware changes. The only real advantage of the IC circuit is the speeds. It is way faster than the Arduino. All in all, there's more than one way to skin a cat, but I personally prefer the Arduino because of its flexibility and low price. I hope you liked this video. As always, don't forget to like, share and subscribe. That would be awesome. Stay creative and I will see you next time.